Welcome to Clear Coding. I'm your host, Stephen Clary. Today's video is one of a series of videos that I uploaded to Vimeo almost 10 years ago, which is why I'm going to look completely different for the rest of this video. But this video is kind of exploring how asynchronous code used to look like before async and await what came on the scene. So, hope you enjoyed this blast from the past, and I'll see you on the other side. Welcome back to Async Time, and today we're going to be taking a look at callbacks, or more particularly continuations. We're going to see how this looks like in continuation passing style. And today we're going to be looking at the easier asynchronous problem, that is download a string from a URL and save that string to a database. Again, I'll start off with the synchronous code real quickly again, just as a review. So in our synchronous code, we'd have something like a string download, and then we'd have a save method that saves it, pass the data in there. And when we actually do our download and save method, I can't type and think at the same time apparently, that would, first we would get the data out and say, just to make it explicit there. So we're going to take our data out of the download, and then we're going to pass that into the save method, and we're done. So this is what our synchronous code looks like. Just as a refresher, this is the simple problem, the easy one. And today we're going to be taking a look at what this looks like when we use callbacks, or more specifically, continuation passing style, or CPS, as it is commonly called. So when we do continuation passing style, the way that these asynchronous methods look is that there's for example, the download method, we're going to pass in, well, actually we don't pass in any data. We just call this method, and when it's done, it'll call back a method that we pass to it. So this is an actual delegate, for example. So that we would have some kind of callback here. Just call that callback, I guess. Or CB. That's a common abbreviation for callback in this kind of style. And similarly, we'd have a save method. When we save the data to the database, we would pass it a string of data, and we would also pass a callback. In this case, there's no result from, no data that we get back from saving it to the database. So in this case, the callback would be a callback of void. So there's a few similarities and differences to patterns that we've seen so far. First off, there's only one member, right? It's not like the event-based pattern that we were looking at last time, where we have a method that starts it, and then an event a separate member that is fired when it's completed. And that does simplify the code somewhat. This style you may recognize from the Node world. It's was very common in JavaScript on the Node side, on the server side, or on desktop programming. And in that case, usually with the Node style, you would actually get a callback that takes two parameters. So you'd end up with an error in result kind of thing, that left and right, all over the place. So it's very, very similar to this. And this style is actually also, although it's not as obvious, it's also very similar to the overlapped pattern in Win32, or the async result if you're on, so the async result begin end stuff, this pattern, if you're on .NET. Although these patterns, the async result, the overlapped, those styles actually don't directly expose the callback. I mean, you do pass in the callback, but then what you get back in order to handle the callback, it's a little more complicated than this more standard continuation passing style, which is a lot more common in functional languages like JavaScript. So we're going to be looking more at a generalized CPS here. And just bear in mind that it has similarities to these other styles as well, like the async result, although the async result pattern has a lot more ceremony around it in order to get it working. Today we're looking at the node, more of a node style CPS, which is a little simpler to deal with. So when we're going to write out our download and save, we are going to consume these APIs, and we're going to produce an asynchronous API in the same pattern, just like we've been doing so far. So we're not going to take any data. Instead, we're going to just take a callback of void. We're not returning anything. Just an a successful failed scenario. So we're going to come into here and say, now the first thing that we're going to do, just like with events, the first thing that we're going to do is issue the download. But unlike events, we can actually pass in a callback here. So we don't have to, wire up an event first. So I'm going to come in here and say, I'm going to take my download result, and if I can spell result. And the first thing I'm going to do is check if there's an error, right? If there's an error, then I'm going to propagate that out through my own callback. So I'm going to call CB with an error of download result.error. I'm just going to propagate that error out and then return. We're done. So we return. Otherwise, I'm going to assume that it's successfully completed. So we're going to save, and we're going to pass that save method the data from the download result. And when that save completes, we're going to get a save result out. And we're going to, once again, propagate any errors. If save result.error, then we're going to say, issue our own callback with that error set to save result.error. And we're going to return. That's done. Otherwise, we're going to call our own callback back with no data. This is the successful completion notification here. Okay, so this is already a definite step in the right direction. We're stepping away from the really base low level events into a callback where we're actually passing around essentially our event handlers. You can think of it that way. We're passing around our event handlers from function to function. And it does make the code a lot cleaner. We no longer have to read it from bottom to top. So we don't start our download at the end. Now we start our download at the beginning. And then we handle our download result. And our next step is save, and then we handle our save result. So you can actually read through it a lot more easily than you can with an event-based asynchronous pattern. There are still several disadvantages. In this example, I still have manual error handling. Some continuation passing style systems can handle this in a little more elegant of a way. But most of them, it's still manual. I mean, well, it actually has to be manual, but they can make it a little bit easier. But the end result is you still have to manually check for an error in your handling here, because the problem is it can't be automatic. Because if you were to just say like download result.data and this threw an exception or something like that, what that would be exposed to is an exception to the callback of the download event. It's not going to actually get propagated out through our callback. So in order to stay into this CPS pattern, we do have to forward the exceptions to or errors to our own callback method. So we still have that manual error handling, and it can look a little nicer than this, but at the end of the day, it's always still manual error handling. We still have deep nesting. Okay. So that problem is still present. It's very similar to what we saw with our event-based asynchronous pattern. We still have deep nesting, or the alternative is you can have multiple methods. And this is, the JavaScript community has come up with the callback hell as a name of this problem, that there's deep nesting going on all the time whenever you have this continuation passing style. And finally, what we're going to look at next time is, just like the event-based asynchronous pattern, any kind of non-trivial logic requires a manual state machine. And we're going to take a look at what that can look like next time. But for now, this is just our basic continuation passing style. Definitely a step above, as we are moving up this hierarchy of different systems of asynchrony. Definitely a step above from events, but we still have a long ways to go. when we compare it to the actual synchronous code, we still have a long ways to go to be as clear, to be as maintainable. There are still several problems with continuation passing style. So tune in next time. We're going to look at this in a bit more depth and look at and observe how state changes the continuation passing style next time right here on Async Time. This is Steve Clary. I'll see you then.
So this concludes our videos from Vimeo that I uploaded from 10 years ago. Unfortunately, I did not finish that video series at the time, and if you would like me to finish this off, leave a comment below, and it's definitely something I would consider. I still have all my notes from this work, and it is actually derived from a conference talk that I used to give many years ago, about that time frame, about 10 years ago, about the history of asynchronous patterns in different code bases, different languages. And it's a topic that I find interesting, because I had to do it the hard way before async and await came on the scene, which really set me up to understand async and await right out of the gate, because I had done it the hard way. So let me know if you'd like to see some more of this. Although if I redid it today, it would probably be all in C#, because that's mostly what I talk about these days. So let me know if you'd like to see me redo this in C#. And if you have any questions, comment below. Thank you very much for watching, and until next time, enjoy coding.